Alright guys, we are doing a good job here simulating different tests, and I think by now you are very comfortable with the many things here in the fluid solver and many options. So let me talk about some things here, like this collision detection. This is the way Houdini detected the collision, like the plane here which collides with our surface here. So we have here two ways. We have particle and move outside collision. This method here is very accurate, or more accurate, yeah, this here fits for the fast moving objects. This is faster, but it makes the collision or the splashes more smoother because it's fast and it's not accurate. Okay, we can here add the ID attribute to the particles, which is beyond our scope, but we can add age to the particles. So we have talked about receding, and separation is not with us. We have talked about droplets, vorticity attribute, and this attribute increases whenever you have swirling or splashing or curling, and in the simulation. So particles that are very swirly and like that we have in the splash. Okay, we have in the splash. So here is the preservation rate, and the more you increase this, the more values you will get of vorticity, and we will use this vorticity attribute, and it's very important to enable it because we will use it in the rendering, and we will talk about this in the rendering section of this course. And here we can scale the attribute of vorticity. So I will set this to 0.25. okay, this is a very unique value, and I use this value in most of my simulations. So this vorticity attribute is the rate of curl, or is just the length of the curls that happens in the simulation. So the more curly you have, the more curls you have, or the more curly simulation you have, you will have different or higher values of the vorticity attribute. So this is for the vorticity, and here we talked about the velocity smoothing. Okay, this is the boundaries. These are the boundaries of my simulation, and yeah, those boundaries here are just related or referenced to the flat tank initial boundaries. And here we visualize the limits. Okay, here we have our collision tab. We didn't talk about this tab, but here in this velocity scale, if it's set just to 1, okay, if we increase this scale, this will make our collisions more stronger, but I leave it to 1. And we have calculated the velocity of the plane. So Houdini will do the simulation based on the velocity of the plane, because we choose this velocity type to be point velocity, okay, which is specified in the SOP. And surely Houdini will calculate it accurately, and you don't have to scale your velocity. So as long as my plane is falling with a real world velocity, it will do more accurate and something that behaves like the real world splashes. Okay, so this is the benefit of a scale, and this is the benefit of using objects that moves in a speed that is similar to the real world. So don't use a car to make a collision with water, and this car is 1 centimeter by 1 centimeter. This won't work at all. Or don't expect that the simulation will be very strong and the collision will be very strong when your car is just moving by 0.2 meter per hour or something, 0.2 kilometers per hour or something like this, which is very slow. Okay, surely those are imaginary numbers, and no one can do something like this at all. Surface extrapolation, when you lower this number, the splash will be more interesting, it will be more dynamic, and the splash will tend to extrapolate or be or goes up more. Okay, you can try this attribute. Viscosity, you can enable viscosity if you are simulating honey or viscous fluids. Okay, and we don't need those. We have talked about the narrowband. Here we have particle separation. The particle radius scale is the point scale, and this is surely a benefit of rendering, but we won't change it here. We will change it when we want to render. The grid scale, here we said before that Houdini, that flip simulations in Houdini is just a mixed technique between the volume simulations and the particle simulations. So what happens is that Houdini creates fields or volumes of the velocity and divergence, pressure, different variables. Okay, and Houdini solves very complex equations to have our velocity, to have the velocity of our particles and pressure, divergence, and applies those volumes or apply those values here of the fields to particles again. So here we have the particle separation. This is the resolution of the particle part of our simulation, and this grid scale is this here is the resolution of the volume part of our simulation. We didn't change this because we have the good simulation, but you can change it and try different values. Surely it will make your simulation slower, but it is a different way to change the resolution of this domain. So this domain here is just divided into voxels, and those voxels, each voxel will have a value. Each voxel has a value of velocity and pressure, divergence, different values, okay, or different variables. So when you have more voxels, surely you will have more accurate simulation, but it will be slower. So when Houdini solves the values in these voxels, it transfers it to these particles and makes those particles move like water. So when you just decrease the separation, it increases the particles, the particle numbers, in contrast to the voxels. When you just decrease this, it will increase the voxel size, so you will have more voxels to fill up this container, and this will slow down your simulation, but you will have more accurate results, and you can just change this and see. Here, closed boundaries, we have talked about this before. Here our y-axis is not closed. Here we have the guides. We have talked about this before, and you can try them. Here you have particles, collision, and different things which you can control by these tabs. Also, I want you to notice that here in the if you press D in the viewport to have the display options, here I think in the geometry I am displaying particles as disks and save this as default, because this gives us this nice looking gear. And I've changed the I didn't change the visualization range of the velocity. So we have talked about a lot of stuff here. Also, we have the sub-steps. Sometimes when you have a small scale simulation and want it very accurate, you can just divide your frames into smaller sub-steps. So here we have two sub-steps that Houdini solves, where Houdini solves equations for fluids. The more sub-steps you have, the slower simulation you have and more accurate results, and this could be of a benefit when you are just trying very accurate small scale simulations. You can maybe do 6 sub-steps per frame, so Houdini will simulate 6. Will divide the frame into 6 smaller units, okay, and will simulate the movement of water in those small subunits. So a frame will have 6 simulation time steps or 6 simulation sub-steps, okay. Distribution is beyond our scope for now. So this is for this video. Thank you.